Good evening. In this video, we will understand how arithmetic mean gets calculated in a continuous series. To do so, first of all, let's have a look at how in a continuous series the class interval can be formed. There are two ways of forming the class interval. One is to put the data in an exclusive class interval form or to put the data in an inclusive class interval form. What is the difference between the two? Let's have a look at it from the example. Here, if I take up exclusive class interval, you will find that the class interval starts from 0 to 10, then the second one is from 10 to 20, and the next one is from 20 to 30. So what you find here is that the upper limit of the class interval gets repeated as the lower limit of the next class interval. Similarly, upper limit of 20 becomes the lower limit of the next class interval. So here you have a look at it and you realize that the upper limit is getting repeated as lower limit of the next class. So if you have to remember from the fact that at the time of counting, you will count from 0 to 9 and you will exclude 10 at the time of counting in the first class. So at the time of counting, where is it going to go? It will get counted in the next class. So from 10 to 19, 20 will get counted in the next class. So if I have to count from 0 to 9, I'll find that there is an interval of 10. Excluding the calculation or excluding the counting, sorry, not calculation, but counting of 10 and taking it to the next class for the counting. Now moving on to inclusive class interval. In inclusive class interval, if I have to remember, how will I remember? Including. Fine. So what is getting included? You find that the class interval here begins from 0 to 9. But this 9 doesn't get repeated in the next class as the lower limit. So in inclusive class interval, the upper limit of the class interval doesn't repeat itself in the next class as the lower limit. Therefore, at the time of counting, if I have to do so, I'll count from 0 to 9. So it will include the upper limit value at the time of counting along with the lower limit value. And therefore, if you count from 0 to 9, you will find that the class interval is of 10. If I have to count the next class, then the counting would be from 10 to 19. So 19 will be included in the counting as it doesn't repeat itself in the next class. Now coming to the calculation of arithmetic mean in a continuous series, we take up a given set of data and we would be doing the calculation by the use of direct method. So direct method is where, let's say, your class interval information is given to you and a frequency is there along with the class interval. So it's like how many number of people or how many number of items are falling in that particular class interval. Where the data is going to be repetitive in nature, there the continuous series formation will be of great help. So let's say people, all those who happen to score between 70 to 80, they will all be getting included under this particular class interval. Yes, of course, we will be excluding the 80th. If let's say somebody has got 80 marks, we'll include that 80 marks in the next class. So at the time of counting, we will count from 70 to 79. So taking up a case here, let's say some people are there who happen to score between 70 to 79 and there are 16 people who are scoring between this particular range. So what we are going to do is, rather than not writing down who happened to get how many marks, somebody might have secured 70, someone might have got 70.5, someone might have got as 75.6. So rather than not taking it to the decimal here and making our work complicated, we prefer to construct a range of those particular marks and then putting all those category of people who are getting that marks between this particular range but not including the ones who have secured 80. So all those people or all those students or all those candidates who may be taking an competitive exam, all those candidates or students in the class, the ones who have secured 80, they will get counted in the next class. Now coming to the formula getting used as I speak of in the direct method formula, since we have a class interval and frequency given to us, what we are going to do is we will convert this class interval by finding out the midpoints. That is, we will make the range into a discrete form. So we'll convert the range into a discrete form by finding the midpoints. And how to calculate the midpoint? Lower limit plus upper limit divided by 2 will give us the midpoint. So what will be the midpoint in the first case? 10 plus 20 divided by 2. So 10 plus 20 is 30. 30 divided by 2 gives us 15. Next one, 20 plus 30 gives us 50. 50 divided by 2 gives us 25. Since there is an interval of 10, what you can do is you can conveniently go on adding 10 to the midpoint that you have got, like 15 plus 10, 25, 25 plus 10, 35. This way it makes it easier for us to form the midpoints. As the interval is not changing, it is remaining the same. So since there is no change in the interval, since the interval is of 10 for all the class, you can conveniently add 10 to get the midpoints. So a quick revision of how midpoint is calculated: lower limit plus upper limit divided by 2. Now then we have a look at the formula. The formula goes as sigma fm divided by sigma f. This x bar, by this time we all know, is average. Sigma stands for sum total. Sum total of the product of the midpoints with their respective frequencies. You take a sum total of the product of the both and you divide it by the sum total of the frequency. So therefore, understanding from the formula itself, we need to have FM column. How do we form this FM column where we put them together? We multiply the midpoints with their respective frequencies and we put them together. Once we have the midpoints multiplied with their respective frequencies, we take a sum total and divide that sum total with the sum total of the frequency. So here we have 3990 and we divide it by 60. This gives us an average of 66.5. Since we haven't taken up the data getting expressed in any one particular unit, so we keep the average as such. Average is equal to 66.5. If it was, let's say, marks, we would have written 66.5 marks. If it was income that we were dealing with and the unit of measurement was rupee, then we would have written here rupees. Fine. So since for this data, we have not expressed the data in any unit of measurement, so we leave it as such. Enough for the session today. Thank you.